Hello, this is Calc 1 on Thursday morning. Sorry I couldn't be with you this morning. Integration by parts is the topic, and just so you know, after you watch this video, I'm assuming you're up in the computer lab. I was going to say Miss Tammy, Miss Lisa has asked that you remain on the floor, the top floor, and not go back down, so she can check on you easily. So if you could do your work, find a spot up on the top floor, tell her where you're going to be, and you can remain right there in the computer lab if that works. All right, integration by parts. I was wondering, and I'm sure you were as well, what is the integral of x e to the x dx? It turns out when we try to do this integral, if we try u substitution, if we pick x to be our u, then du becomes just 1, and nothing will substitute in for each other to fully substitute for both terms, or both parts, x e to the x dx. So no matter what I do, it doesn't work. So we have a new method today called integration by parts. Let me develop the rule for you quickly and show you how to use it in like 3 examples, and then you'll be off on your own to do about 6 of them. All right, so the derivative of a product is my first thing. Let's say the product is some expression called u times some expression called v. So when I do the integral of that, I get the first times the derivative of the second plus the second times the derivative of the first. Sometimes you do it a slightly different order, but it ends up being the same. So the first is u times dv dx. First times the derivative of the second plus the second times the derivative of the first. So this is a u. Let me make sure it's in no way impersonates a v. All right, u. First times the derivative of the second plus the second times the derivative of the first. All right, now I'm going to come in and integrate both sides, and I'm allowed to do that, and that will create, with respect to x, I'll integrate both sides. And when I do that, on the left, the integral undoes the derivative and just leaves me with u times v. On the right, I can divide it up into 2 individual integrals, which you can do when 2 terms are added together. Their integrals can be separated like this. And both of these are with respect to x, so I should put another dx in there and a dx here. This dx will apply to each individual integral. So in fact, let's just get rid of the dx's as if they were algebraic quantities. All right, so now I have, let's gather what's left more clearly. U times v equals the integral of u dv plus the integral of v du. And now I'm going to actually solve that for this. So I have to move this to the other side by subtraction. uv minus the integral of v du equals the integral of u dv. You see, I just moved this expression to the other side. Now, that's actually the rule, but it's sort of in the wrong order, so I'm going to exchange this side with this side. When I say wrong order, it's not in the most helpful order. Integral of u dv equals uv minus the integral of v du. That is the rule for integration by parts. So now that you have that, and why, it all started with the product rule, and it ended up with this. I'm going to use it to integrate that very first one that I had pointed you to, because we've been wondering how to integrate such a thing. So I'll leave the rule in view, and the integral that we're looking for is x e to the x dx. And we are going to work it like this. We are starting here on the left side, and we're going to assign a portion of this expression to be our u and another portion to be our dv. I like to set it up in a box. Always boxing my strategies. And I'm going to divide the box into 4 parts, so it's a rather sizable box. I'm going to put u and v on the top, du and dv on the bottom. When I do these problems, because the formula asks me to identify u and dv, notice it's like on this diagonal. I have to fill in this box and this box. So I am going to pick part of this problem to be u and part of the problem to be dv, and it has to take up the whole problem between those 2 parts. So I'm going to say that this is my u. So I'm going to put x inside of there, and I'm going to put this whole thing in my dv box, e to the x dx. Now, when I do that, I did take some strategy in mind, because I know to finish my box, I'm going to have to fill in du, which is the derivative of x. So I've got to pick something for x that I can easily take the derivative of. And here, to fill in the box, if this is dv, to get back to v, I have to integrate. So when I go from this box to this one, I always integrate. And when I go from this box to this one, I'm always taking the derivative. So in order to do that, I want to pick expressions for u that I can find the derivative of, and expressions for dv that I can find the integral of. So I picked it like this. And sometimes you'll pick wrong, and it'll lead to an expression that is worse than the one you started with. So then you go back and you pick differently. All right, let's fill in the box. This came from the problem. These come from calculation. So I'm going to calculate the derivative of x, which is 1 dx. And then I'm going to integrate e to the x, which is its e to the x dx, which is its own integral, e to the x. So once your box is finished, you fill in this from the problem, you calculate this, then you're ready to throw everything into the formula. So the integral of u x dv e to the x dx, that's just the problem, restate it, equals, here's the answer over here, u times v, which in our box is x for the u, e to the x for the v, minus, in the formula there's a minus sign, the integral of v du. So now we're on this diagonal. So we get e to the x for our v, and our du is dx. You know you've done it properly if this is something you can integrate. And it sure enough is. So let's see what that is. Equals x e to the x minus, well, the integral of e to the x is e to the x plus c. And if you take the derivative of this expression, you will see that you do get back to the original expression that we were trying to integrate. It is the correct answer. All right, let me show you another one, and that's example number 1. Write these down as I go. Number 2, I'll do the integral of x squared. The integral of x squared ln of x dx. And once again, you should always try to use some method we've already learned, like u substitution or just a straight integration, before you go into integration by parts. But this one needs integration by parts. And I'm going to make my uv box. My formula is the integral of v du equals uv minus the, oh, I'm sorry, it's not, is it? It's the integral of u dv, I think. u dv. Sorry. u dv equals uv minus the integral of v du. All right, so, all right, back up here, I'm going to pick those parts. I am going to put u and v on the top, du and dv on the bottom. I'm going to pick along this box. So I'm going to say that this is my u, and this is my u, and this along with the dx, so that'll come over here as well, is my dv. So I'm going to fill in u is ln of x, and my x squared dx is my dv. Now, I didn't have any choice on that one, because if I put the ln x in as my dv, which is the other choice, I'd have to integrate it. And I don't know if you've noticed, but we don't know the integral of ln of x, because we know the derivative of ln of x is 1 over x. But we do not know the integral, so it had to go this way. The derivative of ln of x is 1x, so from u to du we take the derivative. Going this way we have to integrate from dv to v, so we get x cubed over 3 for that part. So that's all there is to it. We're boxed up and ready to go. So our integral of this for this expression will be u times v, which is ln of x times x cubed, come back little box, x cubed over 3 minus the integral of v du. And you're just hoping that whatever shows up behind this integral is integratable. So I should have had a dx. If you notice here, these two boxes always have dx's in them because they are du's and dv's. All right, so back here, is this integratable? Can we integrate this? I think so, because this x reduces that to a 2, and the 1/3 can come out in front. So I'll put the x cubed over 3 out in front, ln of x minus the integral. It ends up being the integral of 1/3 out here, and we will have just an x squared dx behind the integral, which is cool beans. All right, minus 1/3. The integral of x squared is x cubed over 3 plus c. So simplifying everything, our last step, x cubed over 3 ln of x minus 1/9 x cubed plus c. So I'd like to do one more if my video time will allow. Let me shut this down in case I'm over the time limit. And if you would pull up part 2, I just have one more to show you before I make your assignment. So over and out.